Hey, everybody. All right. Well, securing an AWS environment, right? I presume that, if you're here at this conference, at our first ever conference for security builders at AWS, I presume if you're here, this is probably something that you care about, securing an AWS environment. Well, I got this, right? I know how to secure my network. I create security groups with nice least privilege rules for the kinds of connectivity that I expect. And so now I'm not getting connectivity I don't expect. Okay, IAM, roles and permissions. I have identity and access management here, authentication and authorization, permissions policies that are nice and least privilege. I got this, right? All right, well, I got more of these, right? Because my business is growing, and I got a larger environment. I got more of the, you know what, I got this, right? This is just more of the same, right? I got this. Well, okay, yeah, you do, right? Because, as you move to the cloud, and, this has been true for the lifetime, for as long as there's been a cloud, is that automation is the key to success for everything, right? So, in fact, when you have automation, having more of something isn't a significantly different or harder problem than having fewer of them. And you've probably built some automation. It's a good thing. You should. You could go around and build automation. You probably have, and you should build automation that goes around and scans the policies you have, the network configurations you have. Make sure it's all copacetic. But you know what? Really, what you're looking for here, you might have a succinct expression of certain, what I've heard my customers call security invariants, that you expect to hold true across this whole environment. And in fact, more to the point, when you're doing any kind of audit or governance task on this environment, you kind of like to answer the questions with short answers, rather than a long description of everything that all of the thousands and millions of things that you've gone around and audited. And that's what we're here to talk about today. We're going to talk about how you sort of shrink that foundation, shrink that surface area that you need to audit, that you need to look after in order to make sure that everything under here is working the way you expect. You still want everybody to have all the freedom under here, but you want your guardrails to be in place. You want to be enforcing your invariants. Because, there are a number of realities that you've probably encountered if you're an enterprise customer using AWS at scale, right? You've got many AWS accounts. I'm only showing 6 here, but you may have many. You may have ones, you may have tens, you may have hundreds, you may have thousands of AWS accounts that you're looking after. And lots of different groups of different kinds of human users who need to get into those accounts and take different levels of action. You probably also have administrative roles, a security administrator. Maybe some of you are in that role. And you know why we trust the security administrator? Because he's wearing a tie, right? How many of you trust people who wear ties? Is anybody here wearing a tie? No. Well, you know what? Since I know you might have a problem with this, given your sartorial preferences as expressed here, let's make him an astronaut. Maybe we like that a little bit better. But your security administrator needs access to this whole environment in order to be able to secure it at scale, right? And this thing is growing all the time, kind of hard for a human to keep up with. I also have different groups of I have these different groups of people with different levels of skill in AWS, working on things with different security posture. They don't know each other. Sometimes they don't like each other. Needing to get into different parts of my AWS environment. I also have situations like this where I have some kind of data or some kind of resource in my AWS environment that I want to grant access to within the perimeter of my organization, but I want to keep all the outsiders out. I also have a lot of need for connectivity, especially to AWS services from all of these networks. So those are some of the realities that we're going to revisit here as we talk about this topic of enforcing security invariants. AWS Organizations, which I'll kind of start by explaining what that is and what it does, is your key service for being able to set up these perimeter level invariants on your organization. So that's what we're going to talk about today here. And sort of over the course of doing this, since this is a topic that's very closely related to IAM, identity and access management, since this is a 300-level talk, I'm also going to do a few pro tips for writing some really fine-grained IAM policies. So come for the organization, stay for the IAM, I guess. All right. So what is an AWS organization? Some of you know. If you don't, that's OK. I'm going to explain what it is. You know, I might have a lot of different accounts that I'm working with in AWS. If I'm a small business, what I might have done is I might have an account for my production workloads, an account for my development environment, an account for testing. Maybe I have a few accounts for developers to do their science experiments in. From a really large organization, I probably have different accounts per business unit. I might even have different accounts at the granularity level of an individual project or application. So I've got a lot of these, and actually I probably have some sort of a notion of hierarchical relationships between them. And at the most basic level, that's what organizations is. Organizations gives you the tools to organize your accounts in a hierarchical tree of organizational units. And we'll explain what you can do with that with that hierarchy of accounts. But this is how it looks. All the way at the top, there's an administrative account that you'll see in our documentation called a master account. And that's where all of the administration of the organization comes from. Typically up at that master account, you're not running any workloads. That account exists. It's very powerful and exists solely for the purpose of administering the rest of the organization. Okay, well, organizations, what are some things that it lets me do? Well, in a multi-account environment, you know, I probably need a programmatic way to create AWS accounts. So it has an API like that. There's an API you can call to get an AWS account created. There's an API you can call to move your account around the organization. And before we get into all of the security and invariant aspects of organizations, I also want to point out that a bunch of AWS services are integrated with organizations. The most notable one here, the one that I think I can actually see no reason why anybody wouldn't take advantage of this integration, is CloudTrail. You know, many of you as security builders are familiar with CloudTrail. It is it's our audit log for actions taken in your AWS accounts. Well, you can turn on CloudTrail at the organization administrative account. You can just turn it on across your organization, and that way everybody has CloudTrail on. All of the data is coming up into the administrative account. Nobody can turn it off. Nobody can muck with it. Nobody can accidentally delete a CloudTrail. It's all controlled at the organization level, but logging everything from the accounts. You almost certainly want this. There are a number of other integrations: AWS Config, CloudWatch Events. If you're in the organization's console and look at the settings page, you can kind of see what's available here. So there's a lot of things that we allow you to do at the organization level. So this is what the CloudTrail integration looks like. But let's get into this. So what can organizations do for you on this security invariance topic? Authoritative permissions guardrails. All right, let me explain what I mean by that. So back to our picture over here. I had a bunch of different groups of developers and other kinds of job functions getting into a bunch of different accounts. Got an administrator who needs to do everything. And you know, I want to make some statements about what can and can't happen within this environment. Even if the environment's huge, I want to make some simple statements. I kind of want an outer bound on what can go on under here. So let's go back to my organization here. And let's take that team of blue developers over here. This team of blue developers, they, you know, maybe these 3 accounts are their production staging and test environments for the project, for the blue project that they work on. And, you know, I actually want to give these developers fairly broad control over these accounts. I don't want to get in their way. Right? If I get in their way, if I make them, if every time they want a role or a policy, they have to come and file a TPS report with me, we're failing, right? You want to give them the freedom to do what they want, but you also want to know what boundaries they can't exceed. And that is where, that's where a feature called Organization Service Control Policies, SCPs, comes in. So what is an SCP? Well, an SCP, These things are all controlled from the level of the administrative account, the master account, by someone with, high privilege, because they're making rules that take effect over the whole organization. A service control policy is a policy that's attached to an entire organization, like I'm showing you here, or an individual organization unit, or even an individual account somewhere in your organization. They look like IAM policies, but they don't grant anybody access. What they do is they're a statement of an IAM policy that has to take effect throughout the whole organization. They're a limit on the maximum permissions that can be granted anywhere underneath. So let me show you a little bit of an example here. So over here, in these blue project accounts where these blue developers have created blue roles to do blue things to their blue stuff, they're making API calls to AWS services. That's, whenever you're calling one of our AWS services, it's authenticated and authorized via IAM. And that's no different here. This role has permissions that allow or deny it to do various things, and those permissions are being evaluated. Now, when there's an organization service control policy anywhere up the chain, and there can be multiple all the way up the organizational unit hierarchy, what happens in the evaluation is that, so there's the principal policy over here. There's the policy, whatever these people assign to their IAM roles. So that is a policy that can grant access. And then there's a number of other policies here, the service control policies going up the hierarchy here. They don't grant access, but they can take it away. Now, what's the significance of that? The significance of that is that you don't have to worry about how good or bad these blue engineers are at writing IAM policy, right? Because if they write a policy that's more permissive than you wanted, but you wrote a good service control policy, you still know what bounds they're staying in. So, I'm going to give you a couple of examples of things that I see customers commonly doing with service control policies, although I will say that you can do anything with service control policies that you can do with IAM deny policies. The conditions and resources and actions supported are no different. So let's say, for example, it's likely the case that over here in these blue accounts, we're going to be launching some EC2 instances, to run applications on. Now, it might be that this blue project, maybe it's experimental, maybe it's not production, maybe it's not my most mission-critical workload, and maybe I just don't want it to break the bank. I want them to use the lower-cost EC2 instances. I don't want them launching like a P96 128 extra large from these accounts, because I don't feel like paying for that. Whatever they're doing isn't worth it to me. So here's what the service control policy would look like. Give me a second to look at that. As you can see, this is a deny policy. Those of you who know IAM know that IAM has both allow and deny policies. For service control policies, all of these are going to be expressed in terms of denies, which means that there's going to be a little bit of double and triple negative here. I'm married to an attorney, so I'm perfectly comfortable with having 5 negatives in the same sentence and understanding it. But this is something that you kind of have to learn how to read. Okay, so what does this mean? So EC2 run instances, that's how you launch an instance in EC2. This resource clause, it's talking about the instance resource that's involved in the request. And I've got a rule here that I'm going to match this policy if I'm specifying an instance type other than nano, micro, or small, which means if I do that P96 128 extra large, I don't actually think we have an EC2 instance type like that. I'm just exaggerating. If you do specify some other kind of instance type here, it's going to match the policy, and it's going to get denied. Right? So when I'm over here evaluating, and even if these blue developers aren't aware of the fact that they had to restrict their use of EC2 instance types. Even if this is this guy's first day on the job and he doesn't know that his group is limited to these instance types, writes a permissive policy like that, when we go to evaluate it, the principal policy says yes. The organizational unit policy says no. He can't launch it, so he can't launch the instance. I'll give you another example. This is a really common scenario. we offer many regions all around. We offer our AWS services in many regions all around the globe. Now, it's quite typical for a customer to use more than one, to deploy resources into more than one region. Like maybe you have a separate region where you're doing your disaster recovery, backups, that kind of thing. And I'm sure this is AWS, so anything that can be happening is happening. I'm sure there's somebody out there who's using like all of our regions, but it's probably not you. You're probably using only a handful of our regions. And you want to make sure, both for billing containment regions and just so you don't have resources you didn't expect to have there, you want to limit the set of the regions that anybody could be using. Well, that's your security invariant. It's actually an invariant. It could be a security invariant or an invariant for any number of other reasons. So you could write a service control policy that looks like this. How do we read this one? Well, okay, first let's start with this part of it. This means, if I were looking to limit myself to the Frankfurt or Dublin regions, then I would say if this is a condition in IAM that says what region they're talking about in their request. If the request they're making is against some other region, this part's going to match. You notice that up here there's this not action part, and that's because when you're putting a policy in place like this, if one of your regions is not US East 1, we've got a small handful of the vast majority of AWS services are regional. That means you're interacting with that instance of the service in the region, and our regions are very well isolated from one another. But there's a number of services in AWS IAM, Route 53 DNS, CloudFront CDN that they're almost global by definition. They don't make sense if they're regional. So those endpoints will be in US East 1, which means if I'm making a Route 53 call, I do not want it to match this policy. I don't want it to get denied. I want it to work. So I'm excluding there's a list of services in our documentation that you can look at and exclude the ones that you actually do plan to use. So what happens here? They make a request. They're trying to launch an EC2 instance in the Oregon region. That's going to match this policy because it's EC2. It's not on the not action list, and it's not in one of the requested regions lists. So we're going to match this policy, and the call's going to get denied. And that way, once again, if someone over here in this account inadvertently goes to the console, chooses the wrong region, and tries to do their stuff there, they're going to get blocked. So again, you don't need to worry about those mistakes getting made because you've applied a preventative policy to prevent them. Let's do one more. This is one of my favorite scenarios. In fact, this was one that was directly raised to me by a customer when we first launched AWS Organizations with the initial support for service control policies, which was a lot more coarse. This customer said, "Well, we know that." From a deployment safety perspective, changes to DNS are, they're a little bit high stakes, right? How many of you have had an outage due to something about DNS? Right? So we want to be a little bit more careful about who gets the ability to make changes to DNS, to Route 53. We don't want to turn off Route 53. We use it. We like it. But we want to be pretty circumspect about who can do this. Well, if you look over here at this policy, here I'm talking about the principal tag. In other words, I'm saying mostly I don't want people making Route 53 calls, but I do have some principals, some callers in these accounts who should be able to. And in order to designate those principals as being able to make Route 53 calls, I put a tag on them called DNS operator. So if DNS operator equals true, I don't want to match this policy. I want to let their call go through. But anybody else, I want to match this policy so they can't make calls to Route 53. So this principal over here is trying to call Route 53. He doesn't have such a tag. And what we get here is a deny because we're matching this policy. There's no DNS operator tag on this caller, so they're getting denied. Okay. Let's now look at a caller from this account that does have the tag. Well, if I do have the tag, then I'm going to miss that condition, right? Because DNS operator equals true. I'm going to miss that condition the deny will not apply. And when I go bring all these policies together, the organization service control policy isn't matched, isn't part of the evaluation, and the call is going to get allowed. So that's how this works. Now, I know what you're thinking, right? You're security people here. I just said that access to this API call is gated by a tag on the principal. Who protects the tags? Right? Hey, well, you know what? You can do that with IAM too. And in fact, you can do that with a service control policy if you have an organization-wide security invariant on who should be able to write some special tags. How do you protect this tag? Well, might look like this. Okay, now I'm really going to run you through your paces on an IAM policy. So here's what's going on in this policy. Okay, so first off, let's look at those actions. So this is a deny policy. It's a service control policy. IAM tag and untag. Now, as you know, there's a number of ways for tags to appear on IAM. You could be creating a role and specify some tags in that request, create a user, specify some tags in these actions get authorized even when you're not calling them directly, even when you're calling them by way of create role or create user. So whenever I'm changing a tag, I'm always going to go through this action, which means that part's going to match. Okay, resource star, I understand what that means. Okay, so now I want to be really specific about who gets to assign this tag. Now, when you create accounts programmatically in your organization, you'll get a special sort of administrative level role will get planted in those accounts. By default, this is its name, Organization Account Access Role. You can influence that name. You can tell organizations to name it something else. But this role gets planted in your organization, and it's typically a pretty privileged role. It's allowing access from a privileged role in the master account. So this is a role planted in the account used for administration of the account, and maybe I've decided that this is the only role that should get to write this tag. So whoever is writing this, so if they're not this principal, if they're not the special principal, I want them to match this condition so that the call gets denied. And then finally, one last part here. This is a conditional operator called null in IAM. And you'll notice here request tag, that concerns the tag parameter passed into the request. And I want to match this condition and get denied if the DNS operator tag is non-null in this request. So I know I've taken you through a lot of negatives here. So what this all means in English is if they're setting the DNS operator tag, it better be from that organization account access role. Anybody else trying to tag an account, a user or a role in any other way from any other kind of principal in any of these accounts is going to get denied. So that's how you protect tags, because tags are part of your access control strategy, and so it would make sense to include protection of them in your security invariant. Okay, so I hope everybody saw enough IAM just now to last you the rest of your life. But I'm going to talk about actually a couple of other sort of security invariant-like topics that are kind of tied to organizations, because organizations is a very powerful concept because it's kind of shorthand for my accounts. Right? In the early days of AWS, typically you would run out of only one account. And the account as security boundary has got pretty high walls and kind of gave you a good way to work inside there. As you move to more, we keep those walls in place as you move to a multi-account environment, but some places you need to actually reason outside those walls across your organizations. So if you remember this reality from the beginning of our talk here, right? I give a resource, data in an S3 bucket. I'm looking to grant access to my whole organization here. Or actually, more specifically, the thing I really care about, the invariant I really care about here is I want to keep the outsiders out. Okay. And in fact, I want it to be the case that if I'm adding new accounts, that that this will work as well, that they'll have access. And I want this to scale, and I know that new accounts are being created all the time as new projects are being created. And in fact, I, as a security person, I don't want to be the gating factor as more accounts enter my organization. So how do we deal with that? Well, Organizations gives you a way to do that, because Organizations is shorthand for my accounts. So one way, at least to get the part of this that where I'm blocking everybody else out, I could write a policy like this on the S3 bucket. Now, as many of you know, for granting cross-account, whenever you grant cross-account access in AWS, both the caller needs permission and the account where that owns the resource that's being accessed, the resource needs to say that the caller has permission as well. So this is a policy that's attached not to any IAM principal, but to the S3 bucket that's talking about who can access it. So what does it say here? Okay, it's a deny policy, which means nobody's getting access off of this policy, but I'm taking away some access. What I'm saying here is if you're not in if your principal, the principal making the call is not in our organization, they're definitely going to get denied when they call getObject. Again, one simple place from which to look at this. Now, you might be wondering, wait, she didn't actually do what she said she was going to do. She was going to grant access to the whole organization and instead this is a deny. Why didn't I do this one? Well, this one completely works, right? This one actually does achieve the effect of every account in the organization, even new ones that get added, are going to have access to my bucket, so long as the calling principal has the right permission to call this getObject. But why did I go with this one? Well, this is actually, if you're going to be doing a lot of cross-account things, which is often the case if you're working in an organization, I'm going to go a little bit advanced level here with the IAM to show you kind of how this stuff really works, and why I went with this policy instead. In some cases, this policy is appropriate. I'll talk about that in a second. So let's consider 4 different principles in IAM. I've got over here on the right-hand account, the resource owning account. This is the bucket that everybody's going to try to get to. So now, first of all, in this other account, I've got 2 different roles here. I've got a role up in the top left-hand corner. This role has a permission on it that says S3 getObject to that bucket. So the principal says that they should be able to make this call. Down here is someone who I've heard a customer call this this role has let's say no permissions at all. I've heard a customer call this guy no permissions Ned. So no permissions Ned down here. This principal has no policy saying anything about S3 getObject. Up here, same kind of roles, except now we're in the same account as the bucket. Has permission, no permissions Ned. All right, let's go through each of these principles in turn and see whether they have access right now. Over here, this one's easy. Does this principal have access? No. I mean, because over here he has no permission to the bucket, so of course he's not going to get there. So you're not getting permission to access the bucket from here. How about the role with permission in the remote account? Are they going to have access? Yeah, because I got permission over here, permission over here. That's how cross-account access works in AWS. Great. Okay. Next, over here, same account with permission. Of course, that's going to work. If it works from the other account, of course, it's going to work from this account. What's going on with this one? Yeah, somebody's holding a thumbs up. Now, that may not be what you intended. But let me explain to you why it works out that way. For this, you need to understand a little bit about how permissions works out in IAM. So the bucket gives you the bucket grants permission. When you're going cross account, both the resource has to say they have access and the principal has to say they have access. That's because there's 2 accounts involved who need to get involved in this authorization. So both of them have to say that this is a good access. Within the same account, there's only one account issuing the policy. So if our evaluation sees anybody with an allow, and of course nobody with a deny, if we see anybody with an allow, it's going to be allowed. This is actually correct behavior of IAM as defined, but it may not be what you want, right? You may not want this bucket unilaterally granting access within your account because that removes your ability to do fine-grained access control on the basis of these individual. Now, it may be what you want, but more often it's not. And also, I'm going to mention that if most of the principles that you care about controlling the access to this bucket are outside the account, then I would definitely go with this allow statement. It's super simple. Okay, so what if we change that to the deny that we were looking at before? Let's consider these 4 principles. How do they shake out? Well, this bucket's not allowing access to anybody anymore, but it is denying all of the outsiders. Well, within the same account, this principle has permissions. Good. This principle doesn't have permissions. Okay, that's all expected. The problem is I actually wanted to grant the IAM role with permissions in the other account. So how do I do that? Well, I do need the bucket to grant it. So I could write a bucket policy like this that denies all of the outsiders and allows in specific accounts. And as you probably know by now, that this root thing here, it doesn't literally mean root in the account. The word root should probably scare you as a security person. It doesn't mean root. It means it trusts the other account to issue policies that grant permission. That's literally what it means. So you could do it this way. Again, you could also do it with the allow policy across the org. You just need to be aware that if you have a policy like that, it's going to be allowing all of the principals from your same account, which might be fine. If that's fine, you should do it that way. All right, brings us to our last topic here. We've been talking about organizations as a security perimeter, but there's actually another security perimeter available to you in AWS, which is your network. Many of you are probably familiar with the concept of VPC, Virtual Private Cloud. That's your virtual data center in the cloud whenever you are running infrastructure in your cloud environment. Whenever you're running infrastructure in AWS, it runs in your virtual private cloud. This is a network that you control in the cloud. And if you remember this reality here, you have a lot of accounts, and they all need connectivity to these various services. And you're running your applications from within these networks, and you probably have an idea of what kinds of security invariants you want from within these networks. Now, the applications running in your VPC, typically they're going to be, it's extremely common that they're going to be accessing various AWS services. An extremely common case, for example, is I'm running an application on EC2. My application, leaves some application logs behind. These logs are really useful for me for debugging, for analysis, for security investigations. And CloudWatch Logs is our logging service. AWS CloudWatch offers a CloudWatch agent that you can run on your instances that you basically just point it to a location on disk, and it will slurp all of those logs into CloudWatch Logs, where you can apply powerful analysis and other kinds of tools against it. That's really great. That's really cloudy. The question is how you're going to get connectivity. That agent needs to phone home to CloudWatch Logs. The CloudWatch Logs service, unlike your EC2 instance, is not running in your VPC. It's running in the Amazon network. It's an AWS service available on the internet to anybody who wants to call it. Well, okay, if I'm running from my public subnet, the part of my VPC with routability to the internet, this is very easy. I create an internet gateway, and I use that internet gateway to get to CloudWatch Logs. Okay, if I'm running from instead I'm running from a private subnet, well, VPC has something for that too. It's called a NAT gateway, Network Address Translation. Network address translation, what that means is that this instance has outbound access to the internet, but the internet doesn't have routability back to it. What happens very technically, it gets routed to a NAT gateway. This is an AWS managed thing that does network address translation to a single stable IP address, and then out the internet tracks the connection so it can get back. Okay, but so now this instance from your private subnet is able to get to CloudWatch Logs on the internet. But you might be asking, why did I need internet access to get to an AWS service, where the AWS service actually, from my point of view, is part of my application. It's kind of private to my application. The logs that I'm talking to are part of my environment. They're my log groups, and I should be able to communicate with them without going to the internet, which is part of my network part of the network that doesn't belong to me. Well, what can you do about that? Many of our AWS services, including CloudWatch Logs, offer something called a VPC endpoint. What a VPC endpoint does is it projects that service into your VPC. So rather than reaching CloudWatch Logs at whatever 52.something.something IP address that's on the internet, you're reaching it at an address inside your VPC. And in fact, VPC private endpoints will take care of the DNS so that logs.region.amazonaws.com will resolve to that address in your VPC. Everything works out great. You have private connectivity. In fact, you even get private connectivity if you are making the call from another part of the network that you control, your on-premises environment that's connected to your VPC via a direct connector VPN. Now, what can you do with, what does this have to do with security invariants? I've just given you a bunch of connectivity gobbledygook. What does this mean here if you're somebody concerned with security invariants? Well, this VPC endpoint, it's part of your network, you own it, and what you can do here is you can lock it down, you can put a policy on the VPC endpoint that enforces security invariants, not on your principals, not on your resources, not on your organization, but on your network. And that means any software that's running anywhere on your network, if it makes a call to CloudWatch Logs, is going to go through the endpoint, is going to be subject to that policy. It's very common to write policies like this. About 13 of our AWS services support IAM policies on the VPC endpoint. This is a policy that you see really frequently, that if you're using a VPC endpoint, I would recommend looking at if you can do a policy, putting a policy like this in place. Although, just like anything else in IAM, just like any other IAM policy, supports all the conditions, supports all the resources. For example, if I knew exactly which CloudWatch log groups I expect to be used for my network, I could just list them out under the resource part. And then I knew that no other log groups would get advertently or inadvertently written to. What this policy here means is that the callers using anybody using this VPC endpoint, anybody running any kind of software in my network, they better be a part of my organization. So now I've linked one set of security invariants to another because I know they're part of my organizations, and I was really good about writing service control policies and also writing my granular permissions underneath with the IAM permissions. So what I've done is I've taken CloudWatch Logs and brought it inside my network and put a boundary on what could happen from inside my network. So especially if you're security-minded, if you're a security-minded customer, particularly if you're looking at what kinds of data exfiltration, data loss prevention rules you can put in place, it's often really useful to be able to do that at your network level. All right, so we're pretty much at the end here, and I just wanted to leave you with one final thought here. Just because you can doesn't mean you should. All right, what we talked about here is this whole talk was about security invariants, right? The kinds of assertions you can make that cover your whole environment or cover particular organization units, business units, that cover your network, that cover your individual resources. These things are intended to be simplifiers. Now, it is true, you have the full power and glory of the IAM policy language at your disposal, and those of you who have a lot of experience in AWS know exactly how much power and glory that is. You have all of this flexibility and power at your disposal, and you can use it. But remember, these security invariants, they are simplifiers. So keep it simple, right? You know, think about these sort of broad level statements that you might want to make, you know, when you're working with your compliance, when you're working with any sort of audit function. Think about the simple statements you want to make. And if you can encode them in your service control policies, in your VPC endpoint policies, then what you have is a preventive control that does exactly what you say it's doing. You can go more complex than that, but that, sometimes that might muddy the waters as you kind of add a lot of complexity, answer questions with long answers, etc. So keep it simple. Some of those examples I showed you, regions, instance types, these are really commonly used service control boundaries for customers who just want to take the other regions out of the bidding, for example. So we are, service control policies in organizations especially is a really big deal for us. It's a powerful tool. We're talking a lot about it here at Reinforce. So there's actually, there were way more talks about that and related topics that I could fit on a single slide. But I would, if you are responsible for the security posture of an entire organization, service control policies are definitely something worth investing a lot of time in. So thank you very much for coming out here. I really hope that you had a great conference and enjoy the rest of your time here in Boston.